All right, we're going. So welcome to Exam 2 review. Your exam period starts on Thursday, March 28th, and will end on Tuesday, April 2nd. If you haven't signed up for your exam, please, 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 please do that as quickly as possible. So just some quick announcements. So you have a learning reflection assignment. It's called Learning Reflection Assignment First Time. It's regarding your Exam 1. If you haven't done it already, please try to do it before you take Exam 2 so you can avoid making the same mistakes as Exam 1. Review 2 will be held tomorrow night from 7 to 8 p.m. It'll also be recorded and it'll have slightly different problems, but it'll be pretty much the same material. I'll have office hours on this Thursday from 6 to 7 p.m. I'll be there for the full hour or more if people come in. And I will also have office hours by appointment. We can talk about anything you want. We can talk about your learning reflection assignment or any material on Exam 2 that you didn't quite understand. Just send me a message through Canvas and then we can go over that. So Exam 2 information, pretty much the same as Exam 1. You're able to bring in 1 page of your handmade notes. Be sure to write them yourselves. It's a great way to study. You're not allowed a calculator of any type. It should be pretty easy calculations. I looked at it. Nothing should be too difficult. Your Exam 2 covers weeks 7 through 10 for those textbook sections listed. It's written to take you about an hour, but you have 80 minutes. If you go over time, I think you can have up till 95 minutes. But yeah, it's only 1 point penalty for every 5 minutes you go over. So if you're missing a full question, take that 1 point penalty. Here is the full list of the topics that are or could be covered on Exam 2. I won't read them, but here is the full list. It's all available on our Exam 2 information at practice page. And then, yeah, some expectations for today's review is that you have scratch paper ready and you're ready to solve problems. When I ask you to participate, hopefully you can use the annotation button. If you're on a computer, it's in your left-hand corner, looks like the pencil. If I ask you to react, maybe a thumbs up, thumbs down, go ahead and find your reaction button and give me a thumbs up or thumbs down or face, whatever works. And then I might ask you to type in chat, so be sure to do that. And I don't think I'll really answer or ask you guys anything open mic, but yeah, I'd like you guys to use your microphone if you can. There's some points where I will ask you. All right, so just to get started, some basics of this material is your standard form and your vertex form. You also have your factor form, which I didn't really consider, but it was in your quiz. So hopefully these are very familiar, where your standard form is your ax squared plus bx plus c form. You can easily put that into the quadratic formula, so that's really useful that way. You can factor it by grouping, which you should be familiar with, and if you're not, be sure to practice that, because that will probably be on the exam. You're able to find your vertex using that equation there. Hopefully it's familiar. And then your vertex form, it's important because you are able to represent the vertex really easily with your h and your k value. One note is make sure that whenever you're taking the vertex out of the vertex form, that you have a negative sign here. Otherwise, you'll want to flip it before you take out h. All right, hopefully everyone's familiar with that. And then h represents our axis of symmetry, so where our parabola is symmetric on both sides. Okay. So we're just going to do an example problem just to really get some stuff going. How would you guys factor this by group? Try it out yourself. You've got 1 minute. I don't know, go ahead and set my own little timer. Yep. So you want to. All right. It's been a minute. That ran out the whole place. Okay. We've got a few different answers. Um, let's go ahead and see what the answer is. So it is x plus 5 and x minus 1. Did we get that? Let's see. So we've got one answer in the chat. We've got x equals -1 and x equals -5. We've got um, x plus 3 and x plus 2. Okay, pretty close. So when solving these, we want to multiply to 5. So the only thing that's slightly with this is that 2 times 3 is 6. So you're very close. So in this case, you would want to multiply to 5. So we can do 2 times 3, or we can do 5 times 1. Those are the only two options we have. But we also need them to add up to 6. So the only one that adds up to 6 is this 5 plus 1 is equal to 6, because 2 plus 3 is equal to 5. So that's the part. So then we get this x plus 5 and x plus. Does that make sense for you guys? Okay. Yep. And then normally you'll have more than a minute, so don't worry. Typically you'll have more time, so don't worry about that. Okay. Go ahead and move on. So hopefully you guys remember these, your characteristics and how to find. This is something you should really put on your cheat sheet. Sometimes when we're in the test, we might forget which one's which. But your x-intercept is always the value of x when your y is equal to 0. So that's when our points intersect our x line, right? These are our x-intercepts. Our y-intercepts is the value of y when x is equal to 0. So this line here is our x equal to 0. So this right here is our y-intercept. And you also want to be able to know how to find these. So the way I've written it, all we have to do is we set y equals to 0 and x equals to 0, respectively. Put these on your cheat sheet. They'll be really useful. This is how to find the vertex in your standard form. And then remembering the range is all real numbers greater than, or equal to your y coordinate of the vertex. So what does that mean necessarily? Well, that's everything that's above this line here, right? Every single y value, what does that cover? And typically you want to do this in a coordinate form. So if this is like -2, then my range will be -2 to infinity. And hopefully everyone's familiar with that. Okay, we're gonna go ahead and practice this. So does anyone that's able to use the annotate button feel confident using or finding the x-intercepts for the values we just did? And if the annotation button doesn't work, feel free to write it in chat. I can just write it onto these slides. So what's our first step when finding the x-intercept? We want to set y equals to 0, right? So we get but we can also put it in the easier form because we've already factored it in the last problem. Everyone good with this? Okay. Yep, and then we'll solve for our x's. So this first one here, we get x plus 5 equals 0, so then x is equal to -5. And then we get x plus 1 equals 0, so x is equal to -1. So now that we have those, we want to put them in their coordinate form. So we want to set that y equals to 0 for both of them. Okay. Now what about our y-intercept? That's when our x is set to 0, right? So this one's a lot easier because you'll only have one in this case for a parabola. Yeah, so we want to plug in 0 for all of our x's. So we've got 0 plus 5. So it gets bugging out a little bit, so I'll help you there. 0 plus 5. And we want to multiply that by 0 plus 1. So then what do we get? 5 times 1 is equal to 5. Great. And then what is it in coordinate form?
Zero, 5.
Yep. Good job, guys. Okay, any questions on this? We'll go ahead and move on. So now that we've done that, how do we find the vertex and the range for both these equations? So we want to use this x equals negative b over 2a form. Hopefully this is familiar, but we can easily find the vertex using that equation there. So just a quick reminder of standard form, what is our a value for this equation here?
1.
What about our b?
6. Sorry.
And then our c?
5.
Great. Okay, so now we want to plug in to our x form. So what do we get? Negative
6.
over 2 times a, and a is just equal to 1. So then we get -3 as our vertex. But that's just the x value of our vertex, right? So we want to find the y value of our vertex. How would we do that?
Plug it into the standard form.
So we'll get -3 squared plus 6 times -3 plus 5. We get 9 minus 18 plus 5. This goes to -9 plus 5, which is to -4. All right, so then our x is -3 and our y is -4. That makes sense? Okay. So now we want to find our range. How do we calculate our range? That's the value of our, like every single real number that our function hits in y, right? So When we think of parabolas, we can learn a lot about them by just looking at their equation. So whenever they're a value, so in this case, a is equal to 1. Right? So we found that here. When they're equal to 1, or a positive number, does it face up or does it face down? Yep, it faces up. So this is when a is greater than 0, it's less than 0, it faces down, right? Because it'll open downwards, right? So we have a range. So we have in our equation, we have an a that's positive. It's positive 1. So we know that it's going to follow this one. We know that the bottom y value is -4. So it'll look something more like this, where our vertex is here. Now, how do we find our range?
You take the -4 value from the vertex, and then it goes up to infinity.
All right. How about our domain?
That would be infinity in both directions.
Yep, so it goes from -infinity to infinity because we're going forever in that way and forever in that way. Great job. Do you have any questions on this one? All right. So yep, great job. -4 to infinity, -infinity to infinity. So I already did a little bit of it, but if you guys are able to use your annotate, I'll start by doing the vertex because we were able to calculate that, or I did that earlier. And then if you're able to annotate, you can put the x-intercepts and the y-intercepts. And then don't worry about connecting them all. I have the pen, so it's a lot easier for me to do that. You can either click the pencil again. You can draw a little circle shape as well, if that's easier. So it'll give you a nice circle. So it looks like we've got this one here. Got one right here. Got another one right here. And then we've got another one at -5, 0. The circle does not work as well as I expected. It's all right. Okay. And now that we've plotted everything, we're gonna go ahead and connect the dots. And it should be fairly symmetric. Should look like this. Oh, my drawing's a little off, but that's all right. Okay, great job, guys. Or hopefully this is good. You'll probably need to know how to do this. And then if you need another example, our last quiz, we did this on 5. All right, just a quick reminder, our standard form and vertex form, we're gonna go ahead and now go in between them. So going from standard form to vertex form. Do you feel good about it, or how do you feel about it? Give me a thumbs up or a thumbs down. You can use reactions, or if your camera's on, I can go ahead and see them. Okay, got one thumbs up. Or I guess you can give me one of these too if you want. 2 thumbs up. And about a thumbs up. All right. So I won't take too long on this. But to go from standard form to vertex form, we want to use completing the square, right? And I'll go ahead and write us through all of this. Okay. So the first step is to get all of the x terms on one side. Actually, well, our first step is to really check if a is not equal to 1. In this case, a is equal to 1, so we're able to go ahead and get all of our x terms on one side. And then you can, if you're confident in this, you can go ahead and use scratch paper and follow along, or you can just watch. Either way works. And then I'm going to leave a little gap just right here because we'll want to add something. I'm going to subtract 5 from both sides. Great. And now I want to fill in this little gap right here. So the goal is to find a C value that allows us to create a perfect square on the left side. So in order to do that, we can use this formula where we do b divided by 2 squared. So our b is equal to 6. So I'm going to take 6 divided by 2 squared. And now I have to add that to both sides. So what I'm going to get is I'm going to get x squared plus 6x plus, and then this is equal to 3 squared, right? So I'll go ahead and put 3 squared equal to -5. And then we also need to add it to the other side. So 3 squared to this side as well. Okay, now the next step is to solve for our perfect square. So we're going to take it's technically 4 different things from our left side and condense it into a perfect square. So how we do this is we take this first term here, we make it x, and then we'll go ahead and take our plus sign. Sometimes it's a negative sign, but in this case it's a plus sign. And then we're going to bring in this term here, and then which is 3. And then we're going to bring our parentheses and then the squared sign here. And now we want to solve for our k and move it into the other side. So -5 plus 9, or 9 minus 5 is 4. So then our final equation comes to x plus 3 squared minus 4. This isn't necessarily in the perfect vertex form. All we'd have to do is to get our positive right here into a negative, and we can just do x minus 3 squared. And then this technically is a plus -4. But either way, you've got your vertex form. And hopefully this is familiar because you might have this on a test. And this will be pretty useful to know just in general. Do we have any questions on what I've done? All right. And then just in case you're doing drawings, I have it listed here as well. So as needed, that's another detailed way of writing it. And I'll post these slides after, so that way all of the annotations are available. Okay, how do we feel about the quadratic formula?
Love it.
Great. Okay. We've got 2 loves. All right, cool. So I won't write through this, but if you don't have this on your cheat sheet, put it on your cheat sheet and be sure to know how to use it. To solve for x using quadratic formula, we're just gonna grab this whole thing. I wrote it out for everyone, and I'll just quickly run through it here. But you want to find your a, your b, and your c, and then you plug them into this equation here. You should get this, which simplifies under the parentheses into this, which goes into root 16, and then it's a plus or minus. So then we'll break it up into 2 different x values. And then once you simplify everything, you should get x equals -1 and x equals -5, which is what we got earlier. So great job. All right. Keep it moving. How do we feel about solving cube roots? Would we be able to do this? Thumbs up, thumbs middle, thumbs down.
I can't remember how to handle the exponents.
Yeah, so cool. So this one, we want to remember that whenever we have a cube root, we can take it out of the cube root if we have this many, this little number here, this many in the inside. So the first thing I would do is I would factor out everything on the inside. I've done that here. I've broken out the 125 into 5 times 5 times 5. I have all 5 C's, all 6 A's, and then all my 2 N's. And now that I have this, I can group them into threes and then take them out. Because each of these values, it's like 5 to the 1/3, 5 to the 1/3, 5 to the 1/3. And when I add them all together, I can take them out of the, like, out of their little house. So I'm gonna find 3 of these, 5, 3, 5, which is pretty easy. So I know I can take out a 5. So we can take out all the 5s. We won't have anything 5-wise remaining. So we just have one of them on the outside, right? Okay. And then now I'm gonna look at the C's. I can take out 3 of them, but I still have 2 on the inside. So I'll have 1 C out here, but I'll still have 2 of them inside. And then for our A's, I have 3 of them, and I have another 3. So I have 2 groups of 3, which means I can take 2 A's to the outside. So A squared goes on the outside. I don't have anything remaining under the house, so I don't have to write it inside the house. And then do we have enough N's to take out 3? No. So then we have to leave both of them inside. You guys feel all right with that explanation? Sometimes it's easier to see it when it's like visually laid out like this. Okay, I got some thumbs up. All right. So this can also be written. So yep, we got that. This can also be written in this form. It might not be that familiar, but it is more simplified. I won't go too deep into it, but all I've done is I've taken this right here and I've put my 2 terms, my n, right? Do you remember the n over m is the same? Oh, it's not a great variable to use. Let's see. B to the n over m is the same as the n being on the inside and the m on the outside. So all I've done is I've taken that form. So this goes to c to the 2/3, and then this one goes to n and to the 2/3 as well. And then I've just combined them with the ones on the outside. You can also do that just right off the bat from this starting one, but either way, as long as you're able to get to this blue form, this first one here, you should be good to go. All right, so going on, graphing cube roots, do we know what they would kind of look like? You guys remember graphing cube roots?
I do not.
Okay, that's why we're here. So a basic cubic function looks like this. You have an intercept at 0, 0. That's where it starts. It doesn't start anytime before that. It doesn't start after that if you have just p root of x. It also has an intercept here at 4, 2. And that'll always be how that shape kind of goes. And you'll have it's like if you flipped a parabola on its side and then just got rid of the other half, right? It's that same sort of function. Like we can move that up and you'll have your normal x squared function. So now that we kind of remember what it looks like, do we know what x, or the square root of x plus 2? Do we know what that would look like?
The same thing moved to the right twice, two spaces.
Do we have any other? Do you guys agree? So I agree that it is not going up or down because it has to be outside, right? If it was on the outside of the root, it would be up or down. But remember, whenever we shift left and right, the sign is flipped than what you would think it is. So in this case, you're super close. It would actually shift left 2. Is this familiar at all?
A little bit.
Okay. Yeah, and then if you're ever confused, you can always test them easier, or like you can always test some points. So you know if it's like, it'll always be above the x-axis if there's no like plus or minus on the outside. So just keep in mind that when it's on the inside, you shift left or right, but it's the opposite side. There's no real way to, I don't know any real good way to remember this except for just memorizing it. It'll come up all the time, especially when you're graphing other types of functions. Okay.
Is it flipped because at some point we would be setting it equal to 0, and then you'd have to like move it over?
So I don't remember the exact way to describe this
Okay.
phenomenon. So, but moving on, what would this one look like if our basic was just starting at 0 and being 2? What would I do to this function? We already know this
Move it.
first part moves left. 2, -2.
Mhm.
And then what does this do?
Up 1.
Yep. And I get something like that. Yay. And remember that we don't have anything below it. So our like domain starts at that -2 and then goes to infinity. And then what about our range, our y values?
One to infinity. Positive infinity.
1 to infinity. Great. Yep, just be confident in that. Be sure you know how to do this. Maybe write it on your cheat sheet if you need to. I recommend having at least knowing which one shifts it up or down or left and right. That'd be really useful for you. All right, moving on really quickly. Do we remember what extraneous and non-extraneous means? Cool. Yep, so extraneous is like irrelevant, unnecessary, unrelated, inconsequential. Those are all just synonyms of extraneous. So if you get an extraneous solution, that means that it does not give us an equal equation. Non-extraneous is the opposite, so it does matter. It is a valid solution. When you plug it back in, the equal sign stays true. A good example of this was quiz 9, 1B and 1C. 1B, we had both of them as non-extraneous solutions, but 1C, we had one extraneous and one non-extraneous. This is something I would put on your cheat sheet just so if you're flustered during the test or get test anxiety, you can remember which one is which. All right, how do we feel about solving square roots?
Slightly better than medium.
So solving square roots, we're just solving our x values. And then we also want to know if it's extraneous or non-extraneous. So this one, what's our first step that we would do on this one? -1 to both sides. Great. And then what can we do? So we're left with this, right? What's our next step?
Square root it.
Yep, square both sides. And then we get x plus 2 on this side. equals 9. And then we're able to get x by itself by subtracting 2 from both sides. We get x equals 7. Hopefully this is familiar. Great. Sometimes we'll have 2 solutions, but is x equals 7 extraneous or non-extraneous? And how can we check?
Put it back in the equation, see if it equals 4.
Yep. So let's see, 7 plus 2 square root plus 1 equals 4. So what's the square root of 9?
3.
3 plus 1 is equal to 4. Great. So we know that it is non-extraneous. How do we feel about this?
Good. When the extra number is in front of the square root sign, you still just move it across, right? To subtract it first. Like if there was a 1 here. Oops, sorry.
Yeah, if there was a number there, you would want to divide both sides, right?
Divide, okay.
And remember, before we divide, we have to get rid of this term first.
Okay.
Great. All right. Go ahead and move on. So this is just a quick reminder of simplifying expressions with exponents. This will never go away. So this table was on the last review. Make sure you have these on your formula sheets. It's pretty useful to know, and you'll never stop using it. Even I use it to this day in like higher math. This one's really important for this unit, this last one here. I briefly mentioned it earlier where we have our m over n. I flipped the exponents, but it's still your inside divided by your outside number. All right. This one I'll give you guys to take home. So if you want to try it, be sure to just take a photo of it or write it down right now. I think it's a really useful practice. If you're able to do this, then you should be pretty successful on the exam. Just leave this up for another minute. And then I did this really quickly. So hopefully you also get this answer. And if you don't, it might be my fault. But if you do, then that should be okay. Just leave that up for another second. It's also on the recording. Okay. Now we're going to go over some story problems. I realize that these are kind of a harder thing to grasp. So I also made this up. So hopefully it's all right. Yeah, so a baseball player throws a baseball in the air with initial velocity of 30 meters per second. Doesn't really matter for us. The height of the baseball above ground is given by the function, where t represents the time in seconds after the baseball is thrown. We want to find out how many seconds does it take for the baseball to return to the ground. Okay. So I went ahead and solved it, but we can solve it together. So when it says return to the ground, what does that kind of clue us into?
That h function, h parentheses t, is going to equal 0.
Yep.
Because it's
So
the ground 0.
yeah. Yep. Because when we're on the ground, our height is equal to 0. All right. So 0 is equal to negative 5t squared plus 2, 0t. And now we want to solve for t, right? There's a few different ways to do this. What do you guys prefer?
The negative b over 2a. No.
Are we finding the vertex? That'll give
No.
us the vertex. So that's good if we want to find the maximum height it reaches, right? So that's really good. So we can do that later as well. we know it'll look something like that. I don't know exactly the x. We know that our parabola will be upside down. So do we want to factor it? Do we want to use a quadratic formula? What are you guys feeling?
The quadratic formula would probably be
And
easier.
what is the quadratic formula?
The negative b plus square root of b squared minus 4 times a c times c over 2 times a.
Beautiful. All right. So what's our b and your a values?
B is 20 and
then
a
our
is -5.
okay. So when we do this, I'm going to go ahead and plug everything in. So we have negative 20 plus or minus, and then the square root of 20 squared minus 4 times negative 5 times 0, all over 2 times negative 5. Okay, so now I'm going to work a little bit untraditionally, but we'll get negative 20 plus or minus the square root of 20 squared over negative 10. Okay. Does that look right?
Yeah.
Okay. Now, solving this, you won't get numbers like these, but let's using my calculator. Actually, I don't need to use my calculator. So we have 20 squared to the cube root. So we just get 20, right? Because we can ignore both of those. So we get negative 20 plus 20 over negative 10. And we get negative 20 minus 20 over negative 10. So this first one, what do we simplify to?
0 over 10.
Yep. So we just get 0 for this one. And then what do we get in the second one?
4.
Okay. All right. So we have x equals 0 and x equals 4. How do we feel about that? All right. So
Oh,
what was that?
but 0 doesn't make sense. Well, I mean, 0 makes sense because it starts at the ground.
Mhm.
And then so 4 is the number we're looking for.
Yep, because 4 is when it returns to the ground. So in this case, we would only consider the 4. Good job. I guess this is supposed to be t. These are t values. They're second values. Right? Okay. The way that I did this one is I factored it. So what I did is I took out negative 5t from both sides, or from the whole thing, because I have this, you can take out negative 5, and then you can also take out a t from both terms. And then you'll get negative 5t times t minus 4. And then I'm able to break that up when I set it equal to 0, and I'll get t equals 0 and t equals 4. So both of those ways work. We get the same time values. And as you said, we only care about the t equals 4. Okay, this will be posted as well if you want to take more time on it. But yeah, there's always multiple ways that we can solve for these equations. It's useful to know both because sometimes one way is easier than the other, and sometimes we don't have a calculator. All right, so you already jumped ahead, but what if we want to find the maximum height? You said it earlier. You said our vertex form is equal to negative b over 2a, right? So then we already said it earlier, this is our A value, this is our B value. We're able to set -20 divided by 2 times -5. We get here, we get -20 over -10, which is equal to 2. So our x value of our vertex is equal to 2. Well, our x value, or t value, right? So when t equals 2, that's our maximum height. So our ball will go up and then back down. So what if we wanted to find the y value, or our height value? What maximum height? That's our y value, right? So what do we want to do to find our?
We plug 2 into t.
Yep. So instead of having a t there, I'll put a 2. So we know our maximum is at 2 seconds. All right, so we have -5 times 2 squared plus 20 times 2. We get -5 times 4 plus 40, which is equal to -20 plus 40, which is equal to 20. So now we can do our coordinate form, but we know that this here, the maximum height it'll hit is 20 feet. Because this right here is 2 seconds, comma, 20 meters. All right. Good job. Looks like we're doing pretty good on time. All right. Yeah, so we know the vertex is maximum and minimum. So we went ahead and put that vertex. So we used the vertex form earlier, but another way that we can do it is we can complete the square. So I won't go fully in depth, but we're following the same terms as earlier. The only difference is that we would want to check if a is not equal to 1. If a is not equal to 1, then we have to divide every single thing by a, and you might get fractions. So I don't think you'll see anything like this, but it's still useful to know, especially if you're going to keep going higher in math. But I wouldn't stress about this at all. I've worked it out here, and all I've really done is I've found that my a is not equal to 1, so I divided everything by my a value, which was -5. So I divided every single thing by that. And then now that I did that, I found my value by dividing b by 2, and then squaring it, and then I got 2 squared. So then I added it to both sides. So that's step 3. I added 4 to both sides, my 2 squared to both sides, right? So then I took the terms, I took my t down, I took my negative sign down, and then I took that 2 term down, as well as that squared term into my vertex form equation. And then I want to reintroduce a, the original form that we got, the original number we got rid of earlier. And then I have to multiply a to both terms. So I'm just going to keep this one as is, like that. And then when I simplify my constant term, I'll get my h is equal to 2 and my k is equal to 20. So then that gives me the same values. It is a little bit longer. That's why I recommend having your -b over 2a written on your cheat sheet, just in case you need it. This is the other way to do it. This might, if you forget how to do the vertex using standard form, just go ahead and complete the square, put it into vertex form, and the vertex like that. All right, hopefully this is all right. I know I went pretty quickly on this one. But yeah, just remember that you can only do this if a equals 1. You can only do completing the square if a equals 1. And if it doesn't, just make it equal 1. All right, let's do another story problem. And then I believe this is one of the last problems. So Taylor's like out of her bedroom, second floor, 16 feet up. And she needs to find a ladder tall enough to reach her balcony. There are bushes in the way, so she has to set the ladder a distance of 4 feet away. How long does her ladder need to be? Hopefully that we can start thinking of things. Whenever I get a story problem like this, I like to draw a picture. So I've drawn her cute little house. Her balcony is 16 feet up. The bushes make it so that she has to put the ladder a little bit far away, 4 feet. So then how would we find the length of the ladder? Is there any equations that kind of pop up in our brain when we see this?
A squared plus b squared equals c squared.
Right, so the Pythagorean theorem. What, I kind of gave it away already, but which one is which?
C is the hypotenuse,
Yeah,
which is the
so
diagonal one.
yeah, so our hypotenuse is always the one across from our 90 degrees. So Pythagorean theorem only works on right triangles. So it's always the one directly across. Our hypotenuse is always the longest, longest side of a right triangle. That makes sense. Okay. And then does our A or B matter the way we set it up? Is there one that has to be A? Is there one that has to be B?
No, it doesn't matter.
Nope, it doesn't matter. Great job. Yep, the only one that matters is our C value. So we want to find our C value, right? How would we do this? We would set, I'm going to set A equals to 4. So we'll do 4 squared, and then I'm going to set my B equal to 16. Is equal to C squared. Okay, now how do I solve for C?
Square 4, so it equals 16 plus 16 squared, which
Is 256. You won't have big numbers like this, don't worry. And then you'll have C squared. And then now what do we do?
add.
Okay. And then to add those, we get 272 is equal to C squared. Now what do we do?
That would be feet, because it makes sense for the problem.
What was that? We have to
Square
solve
root.
for C. Yeah. Yep, so we have to solve for C, so we have to get rid of that squared sign by square rooting both sides. So C is equal to the square root of 272. Let's see what that is. 16.5-foot ladder is what Taylor will need to get to their balcony. Are we good with this? Do we understand the Pythagorean theorem? Okay, great. And if we have more questions, just let me know. We can go over it more. We can do other problems. All right, so yep, just working through it. Great. So that's all the problems I have for you during this review. We'll have another another review session tomorrow from 7 to 8 p.m. Same concepts, different problems, different pictures. The slide deck has been recorded and will be posted by 11 p.m. tonight. I have some take-home problems for you guys. So if you would like to do them, these slides will be posted. And then after you do them, the answers are on the next slide. And then if you see the second one is familiar, this factor, that one is from one of the quizzes. So hopefully that's familiar and hopefully you remember how to do that. It is a little bit different because we have an x to the third term, right? So we want to use grouping. Exponent one, we want to make sure that we remember what something to the 0 power means, as well as remembering how to flip the negative exponent up or down. All right, and then if you have the time and you want to keep practicing within the Math1010 Review for Exams PDF, these are the different sections that our exam will cover. And if you can do all of these confidently, then you are in really, really good shape for exam 2. This as well will be posted as a slide deck, so if you forget which ones, don't worry. Yeah, the solutions are also posted for these. So I guess the order I would recommend studying is to look over your quiz first. Your quiz is 7 through 10. These solutions are in Gradescope and on your template page. So if you might want to work through them and make sure you can understand everything. And then if you still want to do more practice, I would start looking through these problems. All right, if you guys have no other questions for me.
When it says 1 page of notes, does it mean front and back like it was for exam 1 or just front?
Should be front and back. It should be the exact same as exam 1.
Cool.
All right. Thank you all for coming. Make sure you do your learning reflection first time if you haven't. If you have questions on what you did on exam 1, just let me know. We can always schedule a time together and go through those. All right, I'm going to stop the recording now.